Good morning, we're Team ProSaS, and today our presentation is centered around a low-cost energy storage system as a solution for merchant risk in wholesale renewable investments. So I think it's no news to everyone today that addressing climate change requires the deployment of renewable energy technologies. From the chart on the left, you can see that there's been a continuous rise in the amount of renewable energy technologies deployed in the US. When you think about renewable energy technologies, you think about solar energy, you think about wind energy, and also you think about the fact that these energy sources are intermittent. Now, the intermittence of these sources naturally creates a mismatch in demand and supply for energy, as seen in the dot curve on the left. You can see that during the day, when people are at work, there's a huge mismatch in demand and supply for energy, and this translates to oscillations in prices of electricity over the course of the day. You have zero to negative prices in the middle of the day and very high prices going into in the evenings. Well, these fluctuations in prices create a risky environment for companies like Macquarie investment group that want to invest in renewable energy technologies. Well, the process of creating a risk-free environment can easily be achieved by taking the mismatch in energy demand and supply created during the middle of the day and storing it in batteries. But the problem is, when you look at a typical cost breakdown for a typical PV grid, you observe that battery costs are about 30% of the current total cost, implying that to actually achieve improved storage, we must begin to think about low-cost energy storage systems. Now, the benefit of low-cost energy storage systems essentially revolve around expanding the robust storage capacity for the midday demand dip, and achieving better control over pricing of electricity. And as a result, stabilizing revenue generation and reducing risk for companies like the Macquarie Group. So at this point, the question really becomes what low-cost storage architecture should be invested in. And today we present the magic bullet, nickel hydrogen batteries, and Sancho will be going into the technical underpinnings of a nickel hydrogen battery.
All right, so this table highlights some of the key comparisons between the conventional lithium-ion chemistry versus a nickel hydrogen. So first thing that comes out is the materials cost per kilowatt hour. So nickel hydrogen is much lower, but what's more striking is the cycle life. Nickel hydrogen batteries have more than 10 times the cycle life of the conventional lithium-ion batteries. And together, these two factors come together to lower down the cost of materials cost per kilowatt delivered by more than 10 times. And this chemistry was actually considered for NASA for space applications because of its really excellent cyclability. So what's driving down the cost of these nickel hydrogen chemistry is first the cathode. It bypasses the usage of expensive lithium and cobalt. And also the electrolyte is replaced from organic and lithium salts to aqueous electrolytes, which lowers down the cost. Now, what prolongs the cycle life is two things. So active material cracking is a problem for lithium-ion chemistry, but it's bypassed by using liquids and gases instead of solid active materials. And secondly, the voltage window is smaller for nickel hydrogen, which significantly reduces the side reactions. And these two come together to increase the cycle life by 10 times. So let's now look at the cost analysis to see how that plays out.
Thank you, Chanshu. So the cost analysis was carried out for 3 different categories on the basis of 1 megawatt hour. So the 3 different categories were: one, the no battery situation, where the merchant just supplies energy at on-peak for on-peak period; lithium-ion solution, which is the conventional battery solution; and our proposed solution with nickel hydrogen. On the right, you can see on the right, we see like there is a figure from Quabno Incorporated, which specifically states that about 60% of the battery cost is a material cost. And working specifically on this, we can see a reduced battery cost with nickel hydrogen 13 times lower, which leads to a reduced fixed cost. And using the comparative revenue stream generated for lithium ion and
Thanks,
nickel.
ProSaS team. Time is up. Let's start a Q&A session.
Thank you.
Great. No, thank you for the presentation. Yeah, a couple questions. How mature is the nickel hydrogen battery? Have there been significant deployments to date? Have there been battery projects built at large scale? And how much track record do they have actually operating?
Yeah, so that's a great question. So it is not obviously not a mature business as much as the conventional lithium-ion battery business, but there are startup companies that are working on this, and I believe that there are sort of small projects, but probably not to the scale of huge like solar farms or power plants at that scale, but it's hopefully coming, I think.
To sort of add to
Gotcha.
that,
What?
I think.
No, go ahead. Go ahead.
Okay. So I think I was going to add to that by saying that we understand that the Macquarie Group is also, really interested in investing in developing promising technology. So that's one of the reasons why we were proposing this architecture. And on a team basis, we've also thought about ways to improve the current chemistry for even nickel hydrogen batteries by making slight changes to the catalysts that are used at the electrodes that can even make this technology more commercially viable.
Got it. What do you think are the primary things that that investors would need to get comfortable with, kind of in order to deploy this at scale? So you kind of go through smaller projects in the lab that are fairly small scale, but then making that leap to pouring hundreds and hundreds of millions of dollars into a project, and then needing it to be operational for 10 to 20 years. What sort of things as an investor should we be thinking about as far as risks kind of associated with that investment, and how to get comfortable with those risks?
So I think from the cost analysis, we can see we did our cost basis based on like ProSaS. And I think one of the biggest things with batteries, like current batteries, is something of significance is the cycle life of the battery, which we can see is of like 10 times order magnitude greater than the current conventional technology, which simply means that you can use this battery for a longer period of time, which significantly impact on the profit per cycle. So the profit per cycle here gives the investors some kind of confidence that you'll be getting a steady stream of income. Like I personally feel like the revenue stream is a little bit constant, because you don't have to worry about the off-peak period and the on-peak period, because we can store the amount this energy that is being generated from the sun using these batteries, and then supply it during the off-peak period, which is the period where the cost is slightly higher. And that's like one of the things investors are usually skeptical about. They have to be sure that it potentially gets rid of the erratic nature of this investment environment.
Yeah, I think to just briefly add to that is first, our technology really helps capture the excess midday storage mismatch. And most importantly, this technology is more reliable than typical lithium-ion batteries, because in a typical lithium-ion battery using a grid, you have to go through these phases where you continuously ramp up the supply of energy stored in a lithium-ion battery. But with a nickel hydrogen battery, the thermal management is much more better. And as a result, over the course of the lifespan of your typical PV grid, you're not going to need to even change your batteries. While in the case of typical mature technologies like lithium-ion batteries, you're going to need to change your battery storage system at least 2 to 3 times before over the course of the lifetime of your entire grid. So we believe that this stability conferred by our battery energy technology really makes it promising for long-term investment.
Thank you, ProSaS team. It's time. We'll move on to the next team. Thank you.
Okay.
Thank,
Hey, thank you very
Thanks.
much.
yeah, thank you.
You.